Welcome everyone, I'm Adam. And in this problem, we're going to be verifying the identity tangent to the fifth x equals tangent cubed x times secant squared x minus tangent cubed x. Again, when verifying an identity, what we want to do is show that one side of the equation is equal to the other. And the rule of thumb that we've been using so far is to take the more complicated side of the equation first and work with that. So I think we can agree that the more complicated side is the right-hand side. So we'll start with that. So taking our right-hand side, tangent cubed x times secant squared x minus tangent cubed x. And we want to show that this is equal to tangent to the fifth x. So getting kind of a game plan here, we look at the left-hand side, tangent to the fifth x, all in terms of tangents. I see I have tangent cubed, and secant squared. If I can turn everything in terms of tangents first, maybe I can combine it to get tangent to the fifth. Well, so the problem part is looking at secant squared. Well, if we know our Pythagorean identities, we know that we have a relation between secant squared and tangent squared. Namely, that 1 plus tangent squared x equals secant squared x. So we can use that. So making that substitution, we'll have tangent cubed x times, in place of secant squared x, one plus tangent squared x minus tangent cubed x. And from here, it's just a little bit of algebraic simplification. If we distribute through with our tangent cubed, we'll see what will that give us. Tangent cubed times 1 is tangent cubed x. Tangent cubed times tangent squared, tangent to the fifth x, and minus tangent cubed x. And so taking a look, tangent cubed plus tangent to the fifth minus tangent cubed, well, the tangent cubes will subtract and cancel, leaving us with tangent to the fifth x, which verifies our identity. So we're done there. Now there is just one more way to do this, and we'll take a look at that. So starting again with our left-hand side, say tangent cubed x times secant squared x minus tangent cubed x. Another way to start this is, if you look at this, you might have noticed, well, we have a common term of tangent cubed and tangent cubed. So if I wanted to, I could start by factoring that to the outside. So we could factor out a tangent cubed, giving us, say, tangent cubed x times the quantity would be secant squared x minus 1. Now what can we do with that? Well, we have tangent cubed, and again, secant squared minus 1. We want to get tangent to the fifth, meaning, again, we want to turn everything in terms of tangents. What if we look back at our Pythagorean identity of 1 plus tangent squared equals secant squared? This implies, subtracting 1, that tangent squared x is equal to secant squared x minus 1. So we can make the substitution for secant squared x minus 1 equal to tangent squared x, giving us tangent cubed times tangent squared x, which of course is tangent to the fifth x, which verifies our identity. Thank you very much.